morning, everyone. I want to thank all of the organizers for having me here and this amazing conference, and I've never been to try Swift before, so I'm super excited. So let's table that and talk about creating games with TabletopKit. Again, my name is Mikaela Caron. I'm an indie iOS developer and freelancer, so this means I make my own apps, so that link is a test flight link for my app Fruitful, which is used for meeting people at conferences. I am the host of Swift Over Coffee with Paul Hudson, and we will be doing a live Swift Over Coffee later today and posting our open ballot in the Discord, so everyone can respond to the question that we have, and we'll talk about that. I am an organizer of iOS Dev Happy Hour, like Tim had said, and we changed the time so that people can meet all around the world. And then I am a content creator, so I make content on all the different social medias. You can follow me everywhere. Let's talk about TabletopKit. What is it? So kind of think of it like a board game, except it doesn't have to have an actual board, so they called it TabletopKit. So it's generally some kind of game you'll play on a table. And it gives us different kinds of APIs so that we can create these kind of games that are very common throughout all kinds of table games, like a card or dice, and how they work. Some requirements. This is visionOS 2.0 only and above. So unfortunately, you can't even use it with visionOS 1.0. And because of that, you need Xcode 16. And this can be tested on the simulator, but it kind of is a little bit difficult sometimes, but you technically can do it. So let's start from the bottom. We have a table. The table is defined as the surface the game is played. And it can be any kind of shape and size, so it could either be rectangular or circular. And specifically for how TabletopKit works, a game has one table. We define this by making some kind of struct called table, and we define it on the protocol tabletop. So we give it its shape, some kind of size, and there is an equipment identifier, which this equipment identifier is just a struct that is hashable, sendable, custom string convertible, and it's just a unique ID within our game because everything has to be unique for everything that we're using. Next, we have some seats. So a seat has a pose relative to the table, and think of it like we have a physical table. So to play a game at a physical table, you have to sit down at the table. So that is our seat that we have. And so active players occupy seats, thinking about it in the real world, where you must be sitting at the table to go ahead and play your game. If you were to stand up and walk in the other room, you can't play the game because you're not sitting at the table. So think of it in that real world to visionOS kind of context. We define our player seat using a table seat protocol. And again, this is what players occupy. And it has initial state of table seat state, which is the, just for right now, it's the position. So with TabletopKit, that was loud. With TabletopKit, we configure the game, implement the rules, add effects with RealityKit, and then SharePlay. So let's talk about it by making the game that we all hate, well, love, which is Monopoly. So let's build Monopoly with TabletopKit and continue on with how we've defined everything. We actually have to use a table setup. So the table setup has everything in it that we use to play the game. So we have our setup variable, table setup, and add in the table struct that we had made earlier. We have our seat that we made with the struct. We give it an identifier, and then we have just the position. So 0 and then 0.7, and the rotation is 0 degrees. So if we were going to add more seats, we would just rotate that around the table. And then we add our seat to our table setup. Next, we have equipment. And equipment is everything that is on the table. This would mean the tokens, our cards, and the die. And most importantly, the Monopoly board. So let's start with the board. We have our Monopoly board. We're just defining another struct, and now it conforms to equipment, and equipment is what players can interact with. We have a base equipment state, and that state tells us about all the different equipment we have, so we set its parent to table ID. Seat control is who can interact with this equipment. Because it's the Monopoly board, everybody can interact with it, so we set it to .any. We give it its position, and then a bounding box is just how big is it. We take our Monopoly board and add it to the table setup, like everything else we've done. We have equipment, like our token, so we define this with an entity equipment this time, rather than just equipment. Because of how we made this game, an entity equipment is something that we use to define an entity in RealityKit, which think of it as just a box, some kind of model. So we say it has a parent ID of the table, because that's where this token will sit on the table. Its pose is where is it placed on the table, and then the actual entity that we create in Blender or some other tool to add to the thing. We then have our die or dice, and this is another entity equipment. It has a die state, and it also has tossable representation. So that is kind of why they made TabletopKit, is because of things like this. So it's funny, tossable representation is defined as an object that represents geometric shapes that players can throw during gameplay. When we define it, we are saying the representation of the die is that it's a cube, and its entity is the visual bounds, meaning the size of what that object is. And then we give it its initial state, which is 1, because that's whichever faces up. Where is it placed? On the table. Again, seat control, who can interact with this, and then defining pose and entity. So with this, let's just take a break. This is why they made TabletopKit, because somebody at Apple created an isohedron, which is a 20-side die, and they did the math behind it. So we don't have to do all of this math. Next, we have the cards. So this could be our community chest cards and our chance cards. More entity equipment, and now this one has a card state. So you can see when we define it, we are specifically saying this is a face-down card. We again give it its parent and the entity. So we've made our tokens, we've made the cards, made our die, and the Monopoly board. So basically at this point, we've opened the box. So let's talk about how we actually play the game. We play the game using what are called interactions. Interactions are system gestures generate interactions with equipment. So a system gesture is something like picking up a die and rolling it. And we take that we take the system gesture of picking something up and letting it go, turn that into an interaction that TabletopKit understands. We do this by adding the tabletop game modifier to our reality view. And the reality view is how we're defining the game itself. If you make it again in Blender, tabletop game, and then we have this game interaction object. So looking at that, game interaction conforms to tabletop interaction.delegate. And then inside of that, we have an update function. So a tabletop interaction has several different phases. We have a started phase, update, cancel, and ended. So if we think about rolling a die, we start by picking up the die with our hand. We then have the update, so us moving our hand around. If we were to cancel that, that would be like I take my hand and put it behind my back, because TabletopKit can't interact with that anymore, and it can't track it. So it is explicitly canceled. But if I pick up the die, hold it, and then properly let it go, that would be a proper end to the interaction and complete rolling a die. With that, in our update function, we can track the different phases that we just went through. So you would just have a bunch of if statements for tracking all the different things and what you want to do. But of course, you would make your own custom functions for this. Otherwise, this function would be 1,000+ lines long. And as we heard yesterday from Noah, I don't think we can any of us can write 1,000 lines of code without bugs. Our TabletopKit interactions modify the game state. So this means we are changing things in the game based on these interactions. And we also control who can interact with which entities and what those entities can do. So let's talk about how they would work with a die. So if we have an onFace started custom function, we are tracking, do we have the die? And then setting a configuration, so allowed destination is where can it land. So this is us picking up the die and then holding on to it. And our update phase, we don't want to do anything because all we're doing is holding it and like moving it around, holding it in our hand. So we don't actually have to do anything because the system gesture is just tracking that we're holding it. If we were to cancel that interaction, that would be putting it behind our back, so we don't do anything. TabletopKit and just the visionOS platform knows when we're not holding on to that die. But if we were going to do a successful interaction, we would take it and properly roll the die and let it go, and now it ends. So looking at the die where the gesture phase has properly ended, we make sure we're tracking the die. We say, okay, what's the next value? So that's you rolling it. And then we say, and add an action that we are going to roll the die and give it its value. And then with TabletopKit, with the tossable representation, we toss the die. So you're not throwing it, but you have to gently toss the die. And that says that it has been rolled. And then our last interaction of adding an action to put the die back where it belongs. So you would hold the die entity in your hand, toss it, and then it would automatically go to the right number that we set, and then move back to its starting position. But if we were to do this with the tokens, if we were to start this, we would say, okay, are we looking at the player token? And then set its configuration, which would be where can this token land? Meaning it could land only on the board tiles, which would be somewhere on the board. If we were to then end that interaction, we have to say the player pawn, add the action of moving that equipment and moving it to a proposed destination. Then we have a thing called observers. So this is where we know what we've done because we've added our action. Now we have to figure out what do we do with those actions. So for example, with some reality kit, we know an action has been confirmed. And because that confirmed action, the whole top half of the slide is the very beginning of defining everything. So we're looking at a move equipment action. Where's the destination? It's on the board. And then defining the token, is that the equipment that we're interacting with? And then if all of those things are true, we could say play animation. So if we want to pick up a token, move it to the board, and some animation could happen. That's how we do it. We know the TabletopKit interaction, and then we can observe that interaction to do something else. Let's talk about SharePlay, because playing games is fun, but visionOS is kind of made so that you can interact with others and play games with others. So it turns your app into a shared experience, and SharePlay uses the Group Activities API. We can define a class called Group Activity Manager and conform it to observable. So notice we're conforming to observable as opposed to using the observable macro because we want to track the changes in this class, but we don't actually want it to re-render our view because we're letting RealityKit handle all of that. So this observes everything without constantly refreshing anytime anything changes. And then here, all we have to do is define our tabletop game that we have and coordinate with session, and that's it. That's all you have to do to implement SharePlay. The animations would happen locally, so each individual one would happen on the Vision Pro. And then this game, or it syncs the game state because we've integrated the TabletopKit interactions and every single action that happens, those sync locally. So that's the only piece of data that's sending between them all. And because of that, SharePlay picks that up because we coordinate, and it's done. TabletopKit, we have defined our board. We've defined our token, die, there's houses, hotels, the cards, and we've opened the box and basically defined a bunch of structs for all of them. So now the tables have turned. It is your turn to make a game with TabletopKit. Thank you.